All right, class. Joseph. Thank you, Joseph. Thank you. All right, so this one right here is not part of the PowerPoints, but it should be. This is actually one of the problems that have to do with rectilinear motion. So when we're talking about a position, velocity, acceleration, and stuff like that, that's this problem here. So there's things in this problem that you actually should know, but I have not myself said it out of my mouth. Okay, what is gravity? Can you give me a value on gravity? I'm hearing it. 9.8. Okay, give me the whole thing. 9.8 what? Very good. 9.8 meters per second squared. Now, is that the only unit of measurement that we use? No. What else do we use? We use a lot of feet, don't we? And so if I was actually doing it with my feet is going to be 32 feet per second squared. So that is also going to be important. But this problem right here is going to be in meters. But I just want to throw that out there so you guys actually know. Depending on what problem you're working with, if it's in feet, you're going to use 32 feet per second squared. If you're going to use meters, it's 9.8 meters squared. Meters per second squared. Yeah. Okay. So a rock is thrown straight up with initial velocity of 19.6 meters per second from the roof of a building, and it is 24.5 meters above ground level. Okay, how long does it take to reach its maximum altitude? So, oh, that's why it's frozen. I'm like, why is that no working? Okay, all right, so there we go. And there you go. Okay. So with this one right here, a couple things I actually know. I know that my S of 0 so what does that mean? What is S in my relationship to physics? That is my position. So if you didn't know that off the top of your head, you need to make sure you actually understand that. So S refers to my position. So in this case, S of 0 is going to be my 24.5 meters, right? Okay. And anything else I know? Initial velocity. So that would be my V of 0. My initial velocity is going to be and acceleration. What is acceleration? Very good, 9.8. But gravity goes which way? Down. So how am I going to show that? Very good. So I'm going to say that my acceleration is always acceleration on this one of basically anything. Just say A is equal to, because this is going to help me start my problem. So this is just like the problem that we did yesterday with the second order derivative. All right, you guys ready? I know you guys are still writing down, but. All right. Let me know when you're ready. All right, so when you're ready, pick up your phone and show me that you're just scrolling through, doing nothing instead of actually any of this. To know, yeah, okay. All right, so I'm going to start with my A. Now, I'm going to take the antiderivative of that. If I go antiderivative, okay, if I go from starting with A, which my acceleration, what comes before acceleration when I'm doing derivatives? Velocity. So it's going to be V of t is going to be negative 9.8 t. Anything else? Huh? Plus c. Plus c. But in this case right here, c is going to be specific for this problem. So it's actually going to be plus my v sub naught, which is going to be my initial velocity. That's where we get that. Why is it that? Because in this case right here, I can go back to this problem, and that's going to give me my initial velocity here. Because I'm going to have a coordinate. Remember yesterday when we were doing this, we needed an x and a y, and we had to do it twice, right? One for each order that I was doing. So for my velocity, this one is an ordered pair of 0, 19.6. Right? Okay, and this one right here is an ordered pair of 0, 24.5. So if I'm doing this exactly like I did it yesterday, this one was my C1, and this one came out to be my C2. Right? So same thing, but since I'm going backwards, I'm working with acceleration, velocity, and position. It's not just, see whatever constant that is for whatever my formula comes out to be. So in physics, we actually have 3 that we normally use. We use position, velocity, acceleration, and after that, it would be a jerk, which is going to be the next derivative off of that, which you almost never use it for anything. Okay? So, but when we're actually using regular functions like trinomials, quadrinomials, and stuff like that, where we're doing every single time when we have a whole bunch, and every time we go plus c, we can go plus c1, c2, c3, c4, and keep going up, right? So from whatever it is, so I can get my higher order integration from there. But in physics, we're using these ones right here. And so if I'm going from velocity, from acceleration, the next one up, my antiderivative would be velocity, wouldn't it? And that's where I get my coordinate for that. So that means that initial velocity, so if I'm plugging in my point, okay, it would look like this, okay? So, Blake, you ready? So my point for this, I would plug in 0 for t, if we're doing it like we did yesterday. Was it 19.6 or 19? Yeah, 19.6, right? And this is how we did it yesterday, right? We plugged in 0 for my x, and then we plugged in what my y was equal to, right?
Yeah.
And so it gave me initial velocity of 90.6. And so isn't that the same as just saying initial velocity? Yeah. So yeah, when I have initial velocity, I solve it like this. I could just put it there. What if I did not have initial velocity? What if I had the velocity after 1 second? I would plug in the 1 here, right? I would plug in a 1 here, and I would put whatever my velocity is after that 1 second right there. So I could do it even if I don't have initial velocity. So that was the way that we actually did it yesterday. Today is the way I'm trying to get you guys to see it and read it where, oh, initial velocity is here. I could actually make my formula or my equation here like this. I could just plug that number in there. Okay? All right, good. All right, so we have the initial velocity now. So my velocity problem is, so v of t is equal to negative 9.8 t plus 19.6. Now I have velocity. Now we're going to go up antiderivative again because I want to find position formula. So if I'm doing the antiderivative of velocity, that would give me my position, right? So I would say s of t is equal to, so now we have to do antiderivative here. So let's do the order. What should I do first?
Raise the power.
Raise the power. So it becomes t squared, right? And divide by 2, which is my power. And I still have my negative 9.8. So I'll clean up my math here in a moment, but I just want to show every step in this. Okay, and the next one's going to be plus 19.6 t. Am I missing anything? Plus c. But what is my c on this one? Initial position. So it's going to be plus s sub naught, which is my initial position. So do we know what the initial position was? Yeah, very good. But what if they didn't give me the initial position, they just gave me some position? Could I solve it the same way? I could have. But since they gave me initial position, I would plug in 0 for all of these. So this is 4, was it 4.9? 4.9. Okay, so if I'm doing S of t squared plus 19.6 t plus s sub naught. So if I were to plug in zeros, this over here would be 24.5 is equal to negative 4.90 squared plus 19.6 times 0 plus s sub naught. So again, if I'm not given the initial position, but I'm giving the position at a certain time, I could plug that in and solve for what that would be. So this one right here, zeros, my favorite number, multiply it out, and I get my s of t is equal to negative 4.9 t squared plus 19.6 t plus 24.5. Now, I went through these steps because I needed all of this. I started with gravity, and then I would plugged in my velocities, and I plugged in everything else for there. Now I have this. Now since I have my position function, my whole thing, now I can actually start addressing those questions. What was that first question? Maximum altitude, right? So if it's going to be a maximum, I need to find the what? Derivative of the position, and then do what with it? Equals 0. Very good. Okay, so let's see. I have my velocity right here. I have my velocity, so I could use this one here, right? Set it equal to 0. Divide by negative 9.8. T equals 2. Could have taken the derivative of my position to find it? Yeah. But sometimes, we have it all there anyway. Sometimes you don't. So that's why you need to know what steps to take anyway. Next question says, what is the maximum altitude of the rock? So I know when the position is highest. So that means I need to plug it in where? Position. Very good. I need to use that information, plug it into my position function. So I'm going to do S of 2 is equal to negative 4.92 squared plus 19.6 times 2 . And for the sake of so for the sake of, let's try that f of, I already put it in my calculator at the beginning because I wanted you guys to actually have most of the class to work on homework. So I already preloaded this one with my function. So you could actually do it out yourself or in your calculator, f of 2. So it gives me 44.1. So S of 2 is 44.1. Now, what are my units? Because units are important to get full credit for everything. Just meters. Because it is a position, not a velocity or acceleration. And third one. Third one says, if the rock missed the edge of the building on the way down, it eventually strikes the ground, what is the total time the rock is in the air? Okay, what is it asking for? Okay, so how long means I'm solving for the time. Okay, but for what function? I have 3 functions here. What function am I going to solve for time? Very good. Position. I'm going to solve for time for my position. So my position, S of t equals all right, I can do a couple different things here. And so set this equal to 0. Looks like there's 7s in all of them.
You can take out negative 4.9.
I can? Okay. So if I take out negative 4.9, I'm left with t squared plus oh yeah, forgot it's negative. Minus 4t plus 5? Minus 5. Dang it. Look at you. You guys are pretty good at this. All right. That negative 4.9, okay, that's going to go away because it's equal to 0 there. And so I can end up factoring this. I get t, what's that going to be? What are the products? So multiply to be negative 5, but add together to be negative 4. Negative 5 and positivo uno. So set that equal to 0. So t is a positive 5 and t is a negative 1. Can I throw out one of those answers? Why? Time cannot be negative. Time cannot be negative. So, how long is the rock in the air? 5 seconds. All right, and the last little bit of these notes, a couple things that we know. So I started off and I said my A of t is negative 9.8 meters per second squared. So I can say my gravity is negative, oh, not negative, it's positive, but depending on the direction I'm going. So 9.8 or so for my function, it would be A of t is equal to my negative gravity. My V of t is equal to negative gravity times time plus my initial velocity. And then my last one is going to be my position. So S of t is going to be equal to my negative 1/2 gravity times time squared plus initial velocity t times t plus initial position. So this right here is going to save you a whole lot of time and a whole lot of work. We can get those items by doing all the math all the way through, or we could use this right here to actually help you out. Especially when you're given a problem. These are known unknowns. These are things that you guys know, but you don't know where they go. You didn't know that if we're doing a physics or a rectilinear motion problem, that we're going to end up having just gravity into my problem every time. All right, that being said, I will let you guys go. And homework, I said, is due on Tuesday. And test is Tuesday. You're allowed to have what? One sheet of notes. Now, let's say, for instance, you're actually caught up with all your work. Would you like to see some actual example problems to do? Yes? Hopefully? Okay, because I went and picked some problems.
When is that speech active again?
Wednesday. So the test is Tuesday, and after the test, you probably shouldn't have any homework, so you can go and work on those. Okay. And you also have Friday's an I day. Everyone just thinks of it as a regular day off, even though it's not. You're supposed to be working. But if you want to take a picture of this, this is actually helping you with your notes. Because remember what I said, go through your notes. And right here, 4.1. What are you going to get out of 4.1? Solve related rates, the 5 examples, right here. Review exercises. Now, the review is, this review has to do with the review at the end of the chapter, which is on page 374. And that's what this is referring to, these review exercises. So it gives you item by item for every single type of problem that you want to do. It gives you the review problem to try and one of the AP examples for you to actually go with that